In this video, we are looking into 3D Pythagoras and trigonometry. So the learning objective is just one thing. We're going to learn how to apply Pythagoras and trigonometry in 3D shape. Um, some notes. Pythagoras and trigonometry can only be applied on right-angled triangles. So when it comes to using 3D Pythag and trigonometry, first thing you need to do is to draw a right-angled triangle, which relates to the length that you are working with. So as I said, the key skill is to recognize which triangle you're working with. You also need to be confident using certs when you're not allowed to use a calculator. I forgot to mention about the special exact trig value as well, like sine 30 degrees, sine 45 degrees, sine 60 degree. Hopefully you do remember them. Anyway, have a go at the starter question below. Okay, just a bit of test your understanding whether you remember how to do trigonometry and Pythagoras. All right, pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers for question 1A and B. So question 1A, quite a straightforward trig, SOHCAHTOA, using opposite and hypotenuse sign. So put O on the top, hypotenuse at the bottom. So you get that x equals 7.78. For part B, if you do SOHCAHTOA twice, so first of all, work out that opposite length using a top triangle. And then using this length in here as your adjacent, so opposite over adjacent, that will be 10. And then you get 2.87. For question 2, your final answer should be 2 root 30. If you didn't get that answer, or if you struggle to understand why, I'm going to go through now. So, work on length of AC. To work out length of AC, first of all, you do need to draw a straight line, okay, from A to C. Now, what you realize is from A to C, that triangle, you need, so this is the big triangle we're working on, A, C, and D, right? So we've got 8 centimeters. Now, in order to work out AC, this final length, we can't really work it out if we don't know what's AD. So our attention turns to AD. Now, but how though? Well, look at the question again. Think about what information have you not used yet? Well, I've not used the 9 on the top in there. So maybe what I can do is I can draw a line across and I have another right angle triangle to work with. And that will be, let's call this length E. So BEC. Now it's quite important to label triangles because, especially in 3D Pythag and trig, when you have more than one triangles, it's very important if you label them so you know which one you're drawing about. So BC is 9, I know. I know CE is going to be 5 because that's 3, that must be 5. It's not drawn on scale, so please bear with me. So anyways, that's 5, that's 8, 3, that must be 5. So work out BE, I can use Pythag. So BE squared plus 5 squared equals 9 squared. BE squared equals 81 minus 25. BE equals square root of 56. 56. Now, do cert form, best to use square numbers help you 1, 4, 9, 16, 25. See which number goes into it. I know 4 goes into 55. So I could break the 56 into root 4 times root 14. Root 4 is 2, 2 root 14. That's BE. Now, how does BE help us? We can see BE is same as AD. Therefore, now we can go back in here, and we know now AD equals to, let me use a different color, 2 root 14. Oops. So then we can use Pythag again. So this time, 2 root 14 squared plus 8 squared equals AC squared. 2 root 14 squared, you can do it manually, but we know squaring this will get 56. So that will give us, is 56? Yes, 56. So 56. No, I mean, yeah, 56, right? Yeah, 56 plus 8 squared. So that 1 squared 64 equals AC squared. So add them up together, and you will get AC equals to square root of, so add them up, that will be 120. Using the square numbers again, the biggest one that goes into it is 25. Does it go into it? Oh, 36 actually, there's one more, 36. I know 36 goes into it. That's it. hang on. No, it doesn't. For 4. Anyway, so root 4 times root 30. Root 4 is 2, so 2 root 30 is the final answer. That's AC. Testing. In this example, we are going to look at the 3D shape. You must be wondering on your paper, why is there 4 cuboids? It's just because I'm being considerate to give you 4 cuboids, just in case you want to draw separate diagrams for each question. So I'm being kind, being generous. I know behind the camera you must be praising me, but please don't. Anyway, let's have a go at the question. Question 8. Work out the size of the angle BFA. Now, to work out angle BFA, so join up the B and F together. So, best thing to do, as said, first thing is draw a triangle that relates to the 3 lengths. So BFA, like this. So BAF. And I know that's a right angle because it's a cuboid. I know that's an 8. What else do I know? I know that length DE is same as BA. That must be 3. So work out angle BFA. I need to work out the angle. So using trigonometry, SOHCAHTOA, that must be opposite. That's hypotenuse. That's adjacent. So the one that use opposite adjacent is tan. So tan angle BFA equals opposite over adjacent. So the angle equals to inverse tan of 3 over 8. Plug that in the calculator, you get 33.69 degrees. The question one is around to 2 decimal places, so we'll do that. Okay. Question B. Work out the length of BE. So I'm going to use the second diagram for this, for question B. BE, so from B to E. Right, so it's a big diagonal. So what is the triangle involved in here? Well, the triangle that involved in here will be from the B to E, and then B and A to E. Therefore, we're going to draw a triangle out again. Okay, but this time label our lengths B, A, E. Bay. Right. So, let's have a look. BA, we know is 3. We want to work out BE. So surely we must know AE. But we don't. So we need to work out AE first. So to find AE, oops. Think about what are the triangles we can draw AE, a right angle, but it has to be a right angle triangle. Well, the answer to that one is we're going to use the base, the triangle at the bottom, A, E, and F. Okay, so we'll draw one out like this. A, E, and F. That's why it's quite important we label the lengths. Now we know this AE length is going to be same as in here. So if we can work out this one here, AE, using an orange triangle, then we can work out a diagonal for the BE. So for the bottom, we can see AF is 8, FE is 2. So the question mark, AE squared equals 8 squared plus 2 squared, A squared plus B squared. So AE squared equals, we can use a calculator, so I'm not going to beat around the bushes. So AE equals square root of 68, which is 2 root 17. Use a calculator, it will give you a simplified cert form straight away anyway. So we know AE is 2 root 7. Therefore, we can use 3 squared plus AE squared, 2 root 17 squared equals BE squared. So 3 squared is 9 plus 2 root 17 squared, that will be 68, equals BE squared. So BE is going to be square root of 77, which is 8.77 centimeters. I know there is a formula to find the diagonal for 3D shapes, which is known as the A squared plus B squared plus C squared equals D squared. But do you know what does the 3D in a 3D Pythag and a trig stand for? 3 dimension? Of course not. It means 3 things. Ding, ding, ding. Just like the 3 Michelin stars in a restaurant. These are highest grade restaurant in Europe. We don't consume that artificial, made up, fake meat made by this pot noodle formula.
Jesus. That is disgusting.
In our 3D restaurant, Pythag and trig restaurant. So anyway, joke aside.
LOL.
Reason I don't recommend using this is because when the 3D shape becomes a bit more complicated, you will get confused when to use it. So if you haven't heard of this before, yeah, scrap this. You don't have to know this. So let's carry on with our part C. Work out the size of the angle FHA. So FHA is here. Okay, so FHA. So draw a straight line from F to H. And then, so we can use this triangle FHA. So we're going to draw it out. So question C. Now the right angle is on the HA's F. So here, so that's the right angle triangle AHF. To work out FHA, that means this is unknown angle. Angle. AF is 8 centimeters. Now, we know FH is the same as AE. Now, we found AE as 2 root 17 in the previous question. So that's 2 root 17. But I would suggest you not to use it, because if you made any mistakes in the previous question, you would have made a mistake in here as well. So what I would suggest you to use is the EF or HA equals 2 centimeters. So that will be the better one to use. Okay, so to work out the angle, that's a right angle, sorry. So that's your opposite, that's your hypotenuse, that's your adjacent. So opposite and adjacent is calling for 10. So 10 angle FHA equals opposite over adjacent. So angle FHA equals to inverse 10 of 8 over 2. Plug it in calculator, you get the answer 75.96 degrees into 2 decimal places. And last question, work out the size of the angle BEA. So BEA, again, join up B to E, and then E to A, and A back to B. So what you realize is we're using the same triangle as question B. So B, E, and A like this. So A, E, B. So that, but this time with no choice but to rely on the previous answers. So BE is 8.77, or I will use root 77 instead. AE is root 68, and or actually 2 root 17. And BA is the reliable 3. To work out the angle BEA, you got options this time. So you got hypotenuse, you got adjacent, and you got opposite. So you got all the lengths. So just choose 2 you would like to use. I'll probably use maybe sine, the opposite, and hypotenuse. So sine angle BEA equals opposite over hypotenuse. So BEA equals inverse sine of that fraction, and you will put in a calculator, you get 20 degrees for round to 2 decimal places. Next example, we're going to look at a pyramid. So 3D Pythagorean trick doesn't always just apply into cuboid. Easier question, yes, but a harder question, probably not. So the diagram shows a pyramid. The vertex means the corner, the point E is directly above the center of the rectangular base. Given also AE equals BE equals CE equals DE, which is 15 centimeters. Calculate the angle CAE. What's the first thing we do? Make a triangle, draw a line. So CA and A to E, so AE. So we know the triangle they're looking for is the triangle A to E, E to C, and A to C. So A, E, C, or ACE, ACE. Right, so what do we have? Let's fill in the information of a triangle. What we know is A to E is 15 centimeters. C to E is also 15 centimeters. We don't know AC, even though we can work it out using a base triangle in here. To work out CAE, it's that one. So what can we do? Now, it looks like a right angle triangle, but it's not. Well, maybe it is, but we can't just assume it is. So instead, we have to work out AC. So I smell cosine rule. Right, so to use cosine rule, we need to first find out AC. So we're going to find AC first. Find AC. So to find AC, we're going to use the bottom triangle in here, the ADC triangle, 8 and 6. So this 8 squared plus 6 squared equals AC squared. Now, if you are familiar with the Pythagorean triplets, so what is a Pythagorean triplets? These are the numbers, 3 numbers that are made up using Pythagoras. So like 3, 4, 5, like 3, 4, and 5. So 3 squared plus 4 squared, 5 squared. Another famous one is 5, 12, 13, 7, 24, 25, and that's the 6, 8, and 10. So these four are the famous Pythagorean triplets. Anyway, so 6, 8, anyway, if you work it out, you get AC squared equals 100, so AC will equals to 10. So AC equals 10, brilliant. Let's plug it back in, 10. So cosine rule, so the cos, so that's your A value. So cos A equals B squared plus C squared minus A squared over 2BC. If you forgot about this, make sure you go back to the cosine rule video and brush yourself up on the content about cosine rule. Next, what you do is you can inverse cos that fraction and plug in the calculator. You'll get the angle equals to 38.94 degree. So I told you it's not a right angle. Even though it looks like a right angle, it's not a right angle. Question B. The perpendicular height of the pyramid is from the rectangular base to the vertex E. So that E, we could draw a line down. It's like you're flying off from a roof like a police to break into the window to rescue a hostage. You know, I'm thinking a bit too much. So what we know is there's a right angle in there. And they want to work out the angle between the perpendicular height, which is E. Let's call that point X, for example. Let's call it point X. Between the perpendicular height and the plane AED. So plane AED is the triangle surface, the face that AED is facing towards us, the inclined triangle plane. So they wanted us to work out the angle between that line and to this plane. So I'm going to draw 3D, right? So imagine you're slicing like a triangle from inside the shape. And this triangle is like a piece of the pyramid. So we can draw a triangle out. Let me just use a space in here. So we're trying to work out, let's call this point M, because this must be the midpoint of A and D. So they want us to work out the angle between the perpendicular height, which is EX, and the plane ME. So they want us to work out this angle in here. Okay. So we know that's a right angle. What else do we know? Now, we know XM, the length XM is the same as halfway from C to D. So XM is same as halfway from C to D. So that's 3 centimeters. And then what else? Now, in order to work out that angle, we need one more length in order to use SOHCAHTOA. But we don't know EX. We don't know this length. This length is not 15. We don't know this length. So, but we have to work out one. Now, I'll let you think about which one is easier to work out, EX or ME. The answer is actually through ME. I'll show you why. So ME is the slant height. Sorry, red is a bit too aggressive. ME is here, and we know AM and we know AE because A is 15 centimeters. So we can use that triangle to help us to work out the ME. So I'm going to use the triangle, draw the triangle out. Oops. So let's try it. So that's puppy, by the way. So A, M, and E. Now, when you draw a line perpendicular from the vertical height to any length outside, it must be midpoint. So M is a midpoint. The reason that M is not too in the midpoint, doesn't look like midpoint on this diagram, is because I'm trying to draw a 3D version of it. So I must show you the side of it. Otherwise, it will be flat out. You can't really see the triangle in the middle. So AM is going to be halfway of AD, which is 4. We know AE, the slant height, is 15 centimeters. So therefore, we can work out ME quite easily. So ME squared, 4 squared, Pythagoras, A squared plus B squared equals C squared. I'm going to skip the calculation here a little bit. ME equals square root of 209. Okay. Just plug in the calculator. So if we know ME equals 209, so let me just So if we know ME equals 200 root 209, so then this becomes root 209. So to work out that angle, we now got our opposite. We now got our hypotenuse. So therefore, it's time to use sine. So sine angle MEX equals 3 over square root of 209. So if you plug it in calculator, so the angle equals inverse sine of 3 over root 209 is 11.98 degree. And that's the answer for part B. This is question 1. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Answers. Now, none of them require answers, so require 2 triangles to help you work out, like a previous example I've shown you. For this practice question is more about making you understand which triangle to use to make sure you use the right triangle and label the correct lengths in a SOHCAHTOA. So if you are quite good at SOHCAHTOA, you should get most of them correct. So here are the answers. So practice question 2, this time is non-calculator. Have a go at the question. When you're ready for the answer, you can press play. It's not particularly difficult because it's just a cone, but what's testing you more is about your basic work without a calculator. So H in here, you will have to work out the value of height, which is 6 root 3. And then for part B, testing your exact values of trigonometry, 6 over 12, same as a half. Inverse cos of a half is same as 60 degree. Okay, let me ask you a question. What about inverse sine of a half? What's the angle? Do you remember? If your answer is 30 degree, then that's correct.
Well done.
This is practice question 3, the last practice question of this lesson. Now, this is a frustum. This took me ages to draw this, so please bear with me. Okay, so this perfectly imperfect masterpiece drawing. Oh, trust me, it took me so long to make this, just to draw this out. Anyway, I hope you enjoyed this question. Pause the video, have a go at the question. When you're ready for my explanation, which I'll go through with you at the end, then you can play the video. The answer, first of all, is 19.7 and 66.0. If you got it right, well done. Move on. Brilliant. If you don't, you can hear my explanation. Here we go. So frustum. So what's a frustum? Frustum is by removing a small square base pyramid from the similar large square base pyramid. So it's about similar shapes as well. The height of a small pyramid is 9. The square base of the small pyramid is 8, and the larger one is 24. The slant height of the frustum is h centimeters. So that's the slant height. Slant height means the one that is not perpendicular. Okay, so know the difference between perpendicular height versus slant height. Work out the value of h. Give your answer in 3 significant figures. So it's about similar shape. So a small pyramid and a bigger pyramid, we know the scale factor from, look at the length from 8 to 24, we know it's been multiplied by 3. That means what we know is the 9 vertical height of the smaller pyramid for the bigger one is going to be 3 times bigger, which is 9 times 3, which is 27 centimeters. Okay, now how does it help us? Well, what we can do is, if we draw a straight line inside the perpendicular height, draw it inside like this, okay, and then we can draw it out, and we can draw it like this, okay. Then if we can work out the whole slant height, the h is going to be 2/3 of it, because we know the ratio is 1 to 3. So it means we can work out, first of all, work out the big slant height. So to work out big slant height, let's use this. So we know the height here is 27 centimeter. We know the length here, the base, is half of 24, which is 12 centimeter. Now, why? Because as I've told you in the previous practice question, remember which one is it? Vertical height, perpendicular height down there, and then to the side is halfway through. So half of 24, so that's 12. So work out this slant height, let's call it L. So we can use L, Pythagoras, 12 squared plus 27 squared equals L squared. And therefore, L will equal to square root of 873, which is 29.5 centimeters. Now, for future calculation, I'll probably stick with the square root 873. Next, if the whole length here is 873, root 29.5, that means h is only 2/3 of it because the ratio is 1 to 3. So that's one part, that's 3 parts. We only need this second, that's 2 parts. So we're going to do 29.5. So h equals 29.5 times 2/3. So which is 19.7 centimeters. Next one, part B. Work out the size of the angle between a slant surface and the face of the frustum. So they would like you to work out essentially part B, this angle here. Okay, so part B, to work out the angle, easy. So we know that's a right angle. That's opposite, that's adjacent. So tan theta equal 27 over 12. So theta equals inverse tan of 27 over 12, which equals to 66.0 degree. Now this question, of course, could evolve into finding out the volume, surface area, that kind of stuff about similar shapes. But because this about 3D Python trick, therefore I did not include it in here. But in an exam question, you could expect that.